In this video, we'll be modeling some given data using sinusoidal regression. So we've got a meteorologist, Brian Nodden, recorded the average precipitation in Grand Falls winds over 2012 and created this graph with a sinusoidal regression for the data, where X represents the number of months. So we can see that the graph did have a general sinusoidal periodic look to it, so they used sinusoidal regression. And we have to use the graph to predict the amount of precipitation in August of 2013. So we see January 2012, June 2012, January 2013. So what we want to do is use some interpolation here. So what we can see is that these are 6 months apart. We got January, June, then January. So this would be June again, which means right here is going to be January again, but January of 2014. So August is going to be roughly a little bit less than halfway between these two. So June, July, August, September, October, November, December, January, we're looking at somewhere around here. So if we look around here, that really corresponds to, say, this value here. So if we trace that across, you see we're roughly around a value that's a little bit above 10. So I would probably go with a value of 11 millimeters of precipitation. So for August 2013, we're looking at roughly 11 millimeters, or 11 centimeters, sorry, of precipitation. And in part B, we need to write the equation of the curve of best fit. So we'll see that we're given the sinusoidal regression up here, and we're given A, B, C, and D values. So let's just make sure we write it in the form we're given. So the A value is 4.99. So I have Y equals 4.99 times the sine. I need to open a bracket here. This is a little bit different than the general form we use when we're not doing regression. The B value is 0.5. So I'm going to have 0.5 x plus C. C is 1.58. And then my D value is 14.9. So then I could use this function to determine additional information about precipitation if we modeled this into the future.